Hey, what's up, students? Let's do the good golly, Mr. Jolly. All right, so we're trying to find the green path, we're trying to find the purple path, and we're trying to find the red path, which goes directly from this front top left corner to the bottom back right corner D. So I've kind of drawn on this a little bit. I've added this 22, I've added this 16, added this 100. If you don't draw a picture for this, this one's going to hurt your brain. So I would definitely recommend sketching some pictures, all right? So first of all, let's find the green path. Well, the green path is going to be this 16, so let's kind of save that for later. But then we got to find this diagonal right here. Well, luckily that diagonal is a hypotenuse of a right triangle. What's the legs of this right triangle, you ask? Well, one of the legs is the height, which is 22, and the other leg is 100. So to find this green diagonal, I'm going to take 22 and 100 and square them. I'm going to do the whole move here. So I'm going to do the square root of the legs squared and added together. There you go, just like that. Okay, so this is the Pythagorean theorem in one big move. You take the legs, you square them, add them, and then square root them. That's it. So this green line going across this way is, let's see here, to the nearest tenth is going to be 102.4. I'm going to write that down, 102.4. Well, write that down. I'm going to type it. Here we go. All right, so now I have the green path. Let's even make it green. Can I do that? I can make it bold and I can make it green. Oh, what's up? Let's go. All right, so this green line is 102.4. Okay, so the entire path of the green line, let's go to, can I go to the next slide? Here we go. So 102.4 plus 16. The green path is going to be 118.4. Okay, I might need that here in a second, so let's save that. You're the green path. Let's make you bold and let's make you green. All right, let's find the purple path. It's kind of the same idea. Purple path is going to be this diagonal. And what's that a diagonal of? It's a diagonal of a 100 and a 16. So this can go right here now. Okay, so these are all things that I would sketch separately if I were you. So it's almost the same as this guy. I'm going to swap out the 22 and put a 16 in there. I think I can do that. If the mouse will let me click there. And it took away my power. Well, that's no fun. Wow, why does it keep doing that? It just hates me. Here we go. All right, so if you have a diagonal on a right triangle with one of the legs is 100 and one of the legs is 16, 16 squared plus 100 squared square rooted is going to be 101.3. Nearest tenth, 101.3. All right, purple line, there you are. Purple diagonal, excuse me. All right, so we're going to make you bold. We're going to make you purple. Okay, cool. So 101.3 and 22 added together. So 101.3 plus 22 is going to be 123. So the purple line, the purple path, excuse me, not the purple line, the purple path, the entire path with the diagonal and the side measurements. This one's the length and then this one's the height. Okay, purple, bold. Okay, cool. All right, so I'm going to keep everything on there. Again, if you don't draw a picture, you're going to hurt yourself. So now we have some options here, friends. I'm going to put the 16 back where I got it. Ooh, upside down. Why'd you do that? That's weird. 16, you're going to go back where I got you. 22, I'm going to put you back where I got you. I copied you. Oh, never mind. You're good. Goodbye. We got to find this red dash line. So if you notice, you can kind of see it. Again, if you don't draw a picture, it's going to hurt. But if you notice, the red dash line is the hypotenuse of the purple path. You see the purple path? Look at that. That right angle right there. Boom. That's the hypotenuse. It's also the hypotenuse of the green path. So if you basically, you can get the same answer either way. To find the red path, you just use 16 and 102.4 as your legs, or you can use 22 and 101.3 as your leg. Both will work. Again, the red diagonal, the dashed line, is the hypotenuse of the purple path, and it's also the hypotenuse of the green path. So it doesn't matter which one you use. The red is actually going to be the same. It's going to be, this should be the same length. So let's try that really quick, all right? So let's see here. Let's try 16. So the green and the 102.4. See what we get here. Green and 102.4. 02.4. So according to this, the red dotted line should be 103.6. Well, let's try the other combination. Let's try the purple items. That's going to be 22 squared plus 101.3 squared. Whoa! Ooh! Now this is interesting. I wonder why this one says 103.6 and this one rounds, same thing, 103.6, but this one would round up. I wonder if it had to do with our rounding. So when we rounded these to the 10th, I wonder if that messed with this. I'm pretty sure I have it set up to be off by a 10th or two, so it doesn't matter which one you pick. If you pick this one, you'd say 103.7, excuse me, 103.6. This one you'd say 103.7. Round to the nearest 10th. I do have some leeway because one thing in math is that if you round too soon, then future answers are going to be off a little bit. So as you can see, they're very, very close, but the reason they're off a little bit is because we rounded a little bit earlier. If I were to try something really quick, I know this video is dragging on. Give me 1 second. I should have saved all my work, but I think if we just change, like I think this wasn't this like 101.2 something? It's like 2.8. So there, oh, there we go. See, that goes even closer. You see that right there? I think that's what it was. Let me double check. So that was, so this 101.3, you came from 116. There we go. 100 squared plus 16 squared, square rooted. Yeah, it was actually 101.27. So that goes even closer. Well, not much closer, but it was like 2719 or something. So as you can see, they get really, really close. There you go. So again, if you round too soon, your later answers could be off a little bit. But anyway, that's about it. This video is taking forever. That is the Good Golly, Mr. Jolly.